In this section, we're going to look at functions. So a function is a rule where every input has exactly one output. And the formal mathematical definition is that it's a rule that assigns an element x in the first set, so that in the set of inputs, exactly one element in the output. And those are called the f of x in set B. Okay, so that basically it just is a rule where every input has one output. So let's look at a few examples here. We've got f of 2, so that just means you're going to go in and replace x with a 2. And then work that out. That would be 5. And so we can just write this as f of 2 equals 5. And that would be in function notation, and the as x and y, we're used to it looking like a ordered pair. So that's with x and y, but in function notation, the x is in the parentheses and the y is over on the right side of the equation. Okay, so let's do the next one, f of -1. So we're just going to go in and plug -1 in, and so that would be 2. And f of a, that you can replace it with anything you want. So a squared plus 1. F of a plus h, that's what goes in and replaces x, and then we just copy the rest of it. And then we can actually work this out. A plus h times itself. So that would be a squared plus ah plus another one, so plus 2ah plus h squared plus 1. Okay, so that's that one. And here's that one. And then we had f of -1 was -2. All right, let's look at the domain of functions. So we just have a couple things we need to look out for. We need to make sure that if we have a fraction, the denominator is not 0, otherwise it'll be undefined. And then we also want to make sure that we're taking square roots of actually positive numbers. So in this one, there's no restrictions, 2x minus 1. There's no restrictions. That, if I was going to graph that, it's going to be a line with a y-intercept of -1. A slope of 2, and that just can go in every direction. There's no problems with any x I want to put in there will show up on that line. So the domain would be all reals, and we can show that as going from -infinity for x to +infinity. Or you could say it is the domain of f goes from -infinity to infinity, or the domain of f is equal to all real numbers. Okay, now in this one, there's going to be some restrictions because we don't want to take a square root of a negative number. Okay, so what we do to make sure that that doesn't happen is we take the radicand, whatever you're taking the square root of. It can be 0, that's fine, or anything bigger. So it can be 0 or positive. So we just take whatever's under that square root, that radicand, and set it greater than or equal to 1, and then just solve that inequality. So we would have 2x is greater than or equal to 1, and dividing by 2, we would get x is greater than or equal to 1/2. So now our domain of G would go from 1/2 to infinity. Okay, moving on, let's look at what happens with some fractions. So here I want to make sure that the denominator, when that's equal to 0, then it's undefined. Okay, so that's the big idea here. Okay, so I have a problem when 2x minus 1 is equal to 0. So adding 1, we'd get 2x equals 1, x equals 1/2. That's going to be undefined. So the domain of y would just be everything except 1/2. So go up to 1/2, don't include it, skip over 1/2, get really close to it, and head on off to infinity. So just looking at that domain, we would have everything would be included except at 1/2. There's a little hole in what's allowable for x's. Now on this one, we've got two things going on. We need the denominator. We need to investigate what happens when the denominator equals 0. That's going to be undefined. So that's going to be an issue. And then we also have an issue, let's make a little room here, if the radicand is negative, right, then we would just be taking square roots of negatives, which are complex numbers. That's not a real number. So we need to also set the radicand greater than or equal to 0. Okay, so we're going to do both. Let's see. In the denominator, x squared minus 4, if that's equal to 0, we've got undefined. So if x squared is equal to 4, and that happens twice. If I take the square root there, I've got 2 and also -2. So these are undefined. Okay, so we just make sure we don't let x equal that. Just like here, we did not let x equal 1/2. You just say, okay, if that's undefined, then you're off. You don't get to be part of the group here. All right, now let's look at the radicand. We've got x squared. Oh, I was doing the denominator. Okay, the radicand is under the square root, so that can be equal to 0. We can take a square root of 0 or any positive number. So x is greater than or equal to 1. Okay, so if I was going to go and look at this, here I am at 1. I can include 1 and just have every number heading off in towards infinity, except I have a problem at -2. Well, that's fine because that's not even part of the group there, but we also have a little problem. That is not part of the solution. Okay, so what we need to do is we're just going to go from 1 to 2, but don't include it, and then jump over, get really close to 2, and head off towards infinity. Okay, so the domain of f would be given by go from 1 to 2, including the 1 but not including the 2, and then jump over to 2 but not including it up to infinity. 2. And with functions, we just want to really be able to go between all kinds of different ways of representing this relationship. So we want to be able to use English and describe it as in a sentence, and also write it as an algebraic equation, as a graph, and as a table. So let's look at this example. The function f multiplies x by 2. Okay, so the function f of x, it takes x, multiplies it by 2, and then subtracts 1 from the resulting product. Okay, so we have the description that was given. I just wrote it in algebra, and now I can graph that. We're used to an XY table, but in function notation, the y is replaced with f of x. Okay, so this is, I think I graphed that earlier, but we've got a y-intercept of -1 and a slope of 2. So this is my slope. And the y-intercept is equal to, the y value there is -1. So we can use the slope to move from point to point. So there's the graph. And we can also always write this as a little xy table, but now with functions, we're just replacing y with f of x. So yeah, just plug in those numbers in, and we'll get the same numbers that we would have on our graph. So we'd get -1, 2 times 0 minus 1, 2 times 1 minus 1, 2 times 2 minus 1, that'd be 3.